So, NASA Langley Research Center, we've been doing machine learning now down at NASA for about 6 years. This is my caveat slide. The catch is we're one of 10 different NASA centers. So I am by no means the only person at NASA who's doing machine learning research. We have partners across all of our mission and research centers. If you're familiar with NASA, lots of folks know the big ones, Kennedy and Johnson, where all the launches occur. We also have a number of federal labs or research centers, and we have science centers as well. So we're the closest, so not a big drive for me to come up here today. What we do, we like to brag a little bit that we are actually the first NASA center. We actually celebrated our 100-year anniversary last year. No, NASA has not been around that long. It was actually NACA, the National Advisory Committee on Aeronautics. But we have been located down in Hampton, Virginia now for over 100 years. So our bread and butter down there, as the slides show you, are aerosciences. We're the center of excellence for entry, descent, and landing. We like to point out that there have been several missions to Mars, and Langley has been responsible for all of these successful landings. So we'll leave it at that for our other friends at the NASA centers. We do quite a bit with advanced materials, of course a lot, as you'd expect, with aerosciences. We have quite a few wind tunnels. We're NASA's big iron center that does testing on models. We also do quite a bit with materials, with intelligence systems and autonomy, self-flying aircraft, as well as a pretty respectable science directorate that handles climate science and atmospheric research as well. So we've got a couple instruments up on the space station right now that were built down in Hampton. So you've heard a lot of people talk this morning, and when it comes to implementing whatever you want to say the buzzwords are, machine learning, artificial intelligence, it's clever now because lots of folks have changed that AI from artificial intelligence to augmented intelligence. Still the same thing. It's a big process, and we are the federal government, and we know that we don't work quite as easily as private industry. We have a bit more rules that we have to follow. So I kind of put this up as something we've seen quite a bit, and to put our NASA moniker on that as well. Even the biggest journeys have to begin somewhere. We are the agency that went to the moon. We're going back. We're going to Mars. And so when it comes to investigating things, taking risks, failing forward, we're certainly not averse to that in any way. But what we do know is that there's steps to any successful process. And so what we've done down at Langley, and this started now about 6 years back, was to look at a center-wide strategy. It's now become an agency-wide strategy on how we're going to accomplish implementing some of the things that everyone discussed this morning and will be discussed this afternoon. Kind of an eye chart here, but 3 main ideas with it. We need to manage data, so that's been discussed. I don't think that's a surprise to anyone. Being somebody who's always worked for Uncle Sam, either in a Navy uniform or with a civilian badge on, we manage. We don't always manage very effectively or very efficiently, so that's something that we need to look at. We need to build a knowledge base, so it's not enough, and everyone can appreciate this from your respective agencies, to simply build a data repository or a database. We got a lot of folks that are really good at collecting things, and nobody has any idea what was put in that file cabinet by the time it was done. So we actually need to know what that data is, how to pull that data out, how to connect it with other data sets. That's the knowledge base side. And then the very last piece is the machine learning side. This is the artificial intelligence, cognitive computing, the technologies that do predictive analytics, find patterns. It's really sort of the icing on the cake. I think the first 2 loops there are the part that probably takes about a good 75% of our effort on the projects we work. The big goal, and it was discussed this morning in Dr. Kelly's presentation about the helper, we see that as a positive thing, not a negative thing. Siri on steroids, so to speak, somebody that I can ask as a mathematician very deep questions and get answers back that I couldn't simply Google. So we see that coming. Well, you know, we're on a NASA time frame. That means decades, not weeks or months or even years. But it's out there. And you know, overall, we want a very balanced approach to how we team and move through and do all of this. So you can put some more nice NASA images up. You saw this one this morning too. So you know that sometimes our NASA missions require power, capabilities on a grand scale when we need to get things off the ground. We've got other missions like the rover, our science missions. James Webb Space Telescope's going to be going up pretty soon. So those are really advanced technologies and innovative approaches. You know, that's what NASA's known for, thinking outside of the box and being able to take on new missions. And all of our missions require confidence, precision. You know, as a math geek, I'm going to tell you that's a $5 word called uncertainty quantification. So again, as a math guy, I can always give you an answer. How correct that answer is, well, that's what you really need to ask me. And how confident, if you ask me tomorrow, I'm going to give you the same answer. That's really what that comes down to. And you know, the same thing happens, funnily enough, with missions with machine learning. So some of our data requires really large-scale capabilities. We talked about this, like the cloud, things that Dr. Kelly mentioned this morning that have to occur on a very large scale with very powerful capabilities. Other data is very complex. Certainly that's what NASA is known for, and you're not going to solve this with an off-the-shelf algorithm. So we do build our own. We don't like to reinvent the wheel, but we will modify it to make sure that it works for our systems. And again, like I said, all of our data requires confidence and precision from those models. So if I give you an answer today, you need to get that same answer tomorrow and next week, and we need predictive models that are able to do that. To accomplish this, and this was discussed a bit in some of the panels this morning too, what we look at down at Langley is really sort of a three-step process of assessing, applying, and advocating. So we have experts on our team that are able to look at what's out there, judge it, see what we can use off the shelf, see what we need to modify, apply it to real problems so that for domain experts and for where the rubber meets the road, where things really value, we know that it's going to make a difference. And then advocate, because again, we're the federal government, things don't happen fast, but we all recognize, that's why we have workshops like today, things are moving at a pace where we need to get better at partnering and teaming to do that. So the step two in that, identify capabilities, and you've seen some charts about this too. So we do machine learning, that's kind of our catch-all, and I'll talk to that. With our IBM partners, we spent several years now looking at what we call text analytics and expert systems. So as scientists, as you'd expect, we like to read lots and lots of papers. It's not uncommon for somebody who's worked at NASA for decades to have upwards of 10 or 20,000 papers on their personal computer. To be able to look through that really quickly takes time. And some of these new technologies reduce that time and therefore save time for scientists and engineers to do what they really do best. In that red part of the triangle, the expert systems, we'll talk about that last today. These really are the cool Watson stuff that we like to, the question and answer that we see used in a multiple variety of domains at NASA. So another NASA shot for you, successful missions require a team approach. And I guess we'll go, one graphic drifted there a bit. Perhaps that's scientists taking the stage since we're a research center, but there's an astronaut under there. And the idea is that at NASA, to pull things off, we need the research elements, we need development, we need the folks who are able to machine our parts and build our spacecraft, and we need people who are going to fly them. So you can't say, oh, we're going to have an astronaut do all of that. Impossible. Nor an engineer, nor a researcher, nor a designer, nor somebody who's a fabricator. So we took that same concept, perhaps we took that. If you go to the next slide. So we said, okay, we're going to build that same sort of team. So what we said, and this is again that triangle that you saw before, coming back with the people that are on that team. So I'm the math guy on the team. We've had some statisticians. We have a lot of computer scientists and computer engineers who are able to implement these techniques. And the top of that's probably the most important. We rely on domain expertise. And regardless of the agency that you're with or the company that you're with, if you don't have folks who actually know what should occur and what needs to be predicted and how it needs to be used, you're really wasting your time with a lot of development. So we recognize that. We also recognize that we need to have academic partners. This is the algorithm side for us, the really down in the weeds, how do things work. So we've got a few listed up there. We have several more that we partner with at various levels. And we're also smart, because NASA is not the richest agency, like most of us, to partner wisely with industry and other government. So IBM, of course, I'm standing here today. We've got other folks up there who provide cloud services and scientific services for us. We partner with DoD. We partner as well with all of our other NASA centers and with some of the other federal labs like Jefferson Lab that's just up the road from us. So we try to get a very holistic perspective, see what other folks are doing, and again, like I started off with, try to leverage and share as much as possible to do a good job with that. So step 4, we need to define a process. So we do work in the science realm, and if I went to a scientist and did not have a good process, we're not really going to get anywhere with that. So this is fairly standard, I think, as a graphic. Lots of folks have probably seen this. We borrowed from it. The crisp DM, kind of pretty good basis to do your work and move across with how you need to get things done within your agency. 4 main areas, I touched on this with the top of the triangle. This really goes to what we call generally machine learning. So we have knowledge discovery and databases, and this is really what years ago I would have simply called statistics as somebody going through graduate school. You know, this is something that somebody savvy with an Excel spreadsheet would be able to do 10 or 15 years ago. We can now do that on a large scale. Data mining, very similar to that too, except now rather than simply knowing what's in our data, we're looking to see how data is interrelated, to see where concepts come out and how we can make new connections that may not have been realized before. Even if it's something as simple as a lot of Excel spreadsheets, maybe you never realized that within them and between them, something occurs that you want to keep an eye on. Machine learning, as we define it formal, and again, this is within that top triangle, is really predictive modeling and classification. So we give it data, we often tell it the answers ahead of time so it's able to learn connections, be able to then produce a model that scientists and engineers can use. And reinforcement learning, that's kind of the cool stuff, and maybe the scary stuff, depending on your standpoint that's out there right now. This is the idea that I really don't have to tell it anything. I need to tell it a reward function, and I need to let it find its way through a space. And so we use this with our control and guidance systems. We investigate it with autonomous systems. And what we're trying to do, and this, you hear a lot of the buzzword too of black boxes. This can be a black box, so we want to make sure it's as transparent as possible for the sense that someday soon, and I won't put too much of a qualifier on soon, we're all going to fly here instead of drive here, and have a world where that works. We need to understand how those systems control themselves. All right, so step 5, and maybe this is also step 1. Think big and start small. Again, everyone in here and standing in DC, we often have to start small. We simply don't have the budget to take on exascale projects all the time. So again, we try to be smart about that. If you look over the timeline for us, we kind of started out with a small team, and the philosophy at the bottom on this chart is probably the most important thing. And we said, well, you know what, let's just do everything ourselves. Let's get some really bright folks. We'll build a team of about 10 people, and if there's a problem at NASA Langley, we'll solve it. And we very quickly realized, no, it really doesn't work that way. So we started and we looked at, again, some of those old school techniques. That's when we started working, and we continue to work with the Watson folks being able to do the text analytics. And we started to try to develop lecture series to get everybody at Langley comfortable with these new ideas. We then shifted across, and this is where we are now, like I mentioned, with the reinforcement learning and the deep learning, which now called Watson Explorer. So we'll talk a bit about that, a slide at the end, and how we use that. We realize that every agency within the government loves acronyms. NASA specializes in that. I often feel there are people that may be their day jobs to come up with new acronyms. So if you say something that may be common speak somewhere else, but it's in a NASA environment, transcription, speech-to-text, recognition services often produce something that's not very usable, so we need to know how to do that. We shifted from just telling people stuff to having people roll up their sleeves and do stuff with us. So we shifted from just lecturing to workshops and tutorials. And in the future, and this has been talked too, autonomy and intelligence systems, we know that's where things are going. NASA needs to lead the way with that. Cloud platforms, again, that was discussed this morning in the reasoning for that. And widely available training. So what we mean by that is that we, as a team of about 10 folks, we can't do everything. So if we train the trainer, you know, the old analogy of teach somebody to fish, then we're able to really have a force multiplier for that. So again, that philosophy at the bottom has shifted across from do. We then started a team. We consult a little bit. We know now when it's smart to call our friends at IBM or one of the other companies to say, hey, we need some help with this. We know the things we can solve ourselves, and we know when we can build a team and also try to scope out that effort. I feel like as a NASA representative, I'm doing a good job, and we have presentations too. I never get the technology to work right. So you should all be proud we made it to the moon, because everyone who works with me has the same issue. So identify value. This is, from our side, one of the biggest things. And I know there's a lot to take in this slide. I'll kind of talk through it quick. But when we do projects, in some agencies, some settings, it's pretty straightforward what you need to do with your data. NASA is always about, like I say, it's a very decadal time frame, so 20, 30 years out on technology. The research oftentimes, for the folks who do it, they don't fully understand it themselves. That's how it's cutting edge. So what we do is to find cases where we can say, hey, you know what, machine learning, artificial intelligence, all these data science technologies may be valuable to you. So we go back, start with the old school stuff, kind of going around the clock, counterclockwise there. Knowledge discovery and databases. We do a lot of modeling simulation, huge data sets, Monte Carlo simulations, really complex models, again with a need for confidence on that. So how can we be more efficient not only in analyzing them, but being able to reduce it down? These can take months to come up with a solution on a supercomputer. So if we come up with a surrogate model that can do it in days, that's a huge time savings, a huge resource savings. We do low-hanging fruit too. NASA has a mission support side, just like all agencies do. So we work with our financial folks and our other mission support agencies to help them with their data. We use data mining to look at sensors, as you'd expect. When I mentioned we're big iron with a lot of wind tunnels, we have a ton of sensor data, both on models in wind tunnels, on flights that are being tested, experimental and ground tests, as well as physiological sensors with our Human Exploration Mission Directorate. So we have a lot of folks that are collecting data on humans, which is incredibly difficult to mine because of the complexities involved with that. And we look at cutting-edge stuff using lasers with powdered metal to make rocket nozzles right now, and being able to understand how we can do additive manufacturing in NASA domains. The reinforcement learning down there in the lower left, I've talked about the path planning, trying to get the transparency with that, and how do humans interact with those sorts of systems. And then kind of drink from the fire hose on the right side, and I won't go too deep. Happy to talk offline if one of these really strikes a note for something you work on and you're interested in. But we've used machine learning to detect cracks in carbon fiber composites, so advanced aerospace materials, to do that automatically. We've used it to attempt to predict a pilot's cognitive state during flight. So when something goes wrong, if I'm a pilot, am I distracted? Do I get too focused? Am I completely surprised by it? We've worked with our hypersonics folks for operability regimes, our climate scientists to update models that really haven't been examined again since the 80s, simply because there's so much data. How do you do that efficiently? Multi-fidelity models I talked about with the resourcing, and then again with the sensors, we have an entire branch that we work with to be able to come up with more general types of methods that can be used with a variety of different sensors. So again, the takeaway with this is not to read everything, but the gray are the methods that we use. The blue circles are some of the projects we've done. And what you should say is, this stuff's kind of connected. We reuse a lot of things, and that's a takeaway too, to be smart about when you specialize and start out these efforts, and this has been our learning with it too. When we begin a project, we very carefully document what we're doing and how we're doing it to make sure we understand those methods and how they can adopt and adapt to different domains. I do this overlay to say, hey, you know what? We can also use a lot of the same platforms for this kind of stuff. And again, from a federal standpoint, we don't always have a lot of money. And we've heard some folks talk about this too. So what we've done is to say, you know what, this is a world that's rapidly developing in a very open space. You know, there's folks around the globe right now developing in Python and R and TensorFlow and all these software languages that are primarily somebody doing it on their own time and then pushing out tools that everyone can use. So why don't we try to play in that space too? So we partnered with our IT security folks, with our procurement folks, with our Office of Chief Counsel, our legal folks, to make sure we're not violating agreements within the government, to say, hey, we want to use something. How long is it before we can use it? And it's gotten down to the point that for a lot of things, we can sometimes get approval the same day for our guys to use a new package that's rolled out, which has been a big win for us. Again, it's partnering with that recognition that cybersecurity has to be a very inherent part of the work that we do. It's not just math and science. All right, so now for some of the cool IBM stuff to talk a bit about too while we're at the conference. So this is a screenshot about Watson Explorer. And I mentioned this before. I, again, won't go too far into the science stuff and given the time that we have, but I do want to talk a bit about what we found to be highly valuable at NASA, which I think is very pertinent for all the folks in the room, regardless of the agency you work for, is text analytics. So one thing I think, again, as a military and civil servant my entire life, is the government's really good at publishing stuff. And we really like to make lots and lots of pages. And you know what we also do pretty well, too, is we organize that stuff in a way that if you take time, you're able to suss out what it's really about. There's subsections, there's headers, there's common terminology. And if there was only a way to look at all of that and to say, instead of having to sit and read through an 800-page document, I can very quickly pull out salient content. And I can see not only for that document, but other documents related to it. And so what we've done with a lot of our folks down there, and you can see the bulleted list on the left-hand side, is to develop a series of collections using Watson Explorer tool to be able to bring value to researchers. The list is somewhat in chronological order. It also happens to be somewhat in size order. So the Space Radiation Collection, that's with our researchers from the Human Exploration Mission Directorate. These are the folks who are doing the research to make sure astronauts will survive and be healthy on a Mars mission, both back and forth because of the cosmic radiation that exists between the Earth and Mars. There's a lot of cross-domain research on that. And you can obviously understand that our partners in the Department of Defense have a vested interest in understanding how the human body reacts to radiation. Maybe not for the same reasons that we do, but the bodies are the same, the reactions are the same. There's pharmaceutical research to mitigate that. There's materials research to mitigate that. How do you design the spacecraft? We are currently at more than 500,000 documents in the Space Radiation Collection for that particular researcher. That branches across 3 different NASA centers, about 5 different NASA research elements. And what this has allowed that researcher to do is to see themes develop across domains, to know who important researchers are, and to get all of those results in seconds, and to be able to visualize them in a very meaningful way. We demonstrated this again when we talk about value to stakeholders a couple of years back when we first started working it. And the response was extremely positive. And it was a group of folks who said from our headquarters level, you know what, wow, this is stuff we've only dreamed about being able to do. So I bring this up because it's, to me, a really good example of something that the media doesn't talk a lot about. The media likes to talk about self-driving cars, facial recognition, predictive analytics. You know, we all know now that it seems that if you Google something about the hockey game that occurred last night, you get recommendations on tickets to the next one almost automatically. Almost seems like it listens to you sometimes. So there's a lot of things out there that are a little bit scary, a little bit hokey, a lot of buzz. This is one when it comes to text that we found a lot of value in down at NASA. And more folks see the value for this, especially from our missions side, to be able to have basically the call center idea. If something goes wrong with your refrigerator and you call GE and you say, hey, my ice maker doesn't work, they've got somebody who pulls up a system and can give you answers for that. These same systems can do that at NASA when there's anomalies on flights. And it allows engineers and the mission control folks then to be able to do that very quickly. So we're having those conversations as well. So we talked a bit about that, looking through thousands of articles, getting those trends, visualizing the experts. And we've done this with a lot of domains. We work closely also with our NASA Engineering and Safety Center folks on this. They're very interested with it, as well as our model-based engineering folks, so it's very applicable to a variety of domains. I'll be honest with you, it's a little tricky. We've got a full-time guy that does this, and I work closely with him. It's not tricky software to use. I like the interface. It can be a little bit of time to get it set up to work correctly for you, but man, when it does, it's powerful stuff, and we've got good results with it. So that's our leverage capability. This is our understand jargon. So this is connected to the Watson Explorer stuff when we talk about text. We have across NASA, it's a pretty cool place to work. So I've got gray in my beard. We've got lots of folks with lots of gray in their beard. And it can be hard to get people to leave because NASA is such a cool place to work, but they're going to leave at some point. And before they do, it would be really great if we could capture their knowledge somehow. We know they publish papers. We know that they've got work out there. But it's a lot nicer to be able to have conversations with them. I'm trying to avoid NASA speak today and acronyms with everybody, but back home, that doesn't happen. I sometimes wonder, can we have an entire 30-minute conversation only using acronyms? It does seem possible. We're actively researching that. So what we do is use natural language processing to have the speech to text. And then we actually partner with Virginia Tech and Old Dominion locally down in Southern Virginia on this. So we have machine learning that can classify those acronyms and jargon in real time. So as I'm speaking, if I use a term like SAGE, which is actually an atmospheric instrument on the space station right now, that also happens to be a color, an herb, a name. So I could say that Sage is wearing a Sage shirt and Sage perfume and working on Sage. This is able to actually pull out each of those and say, person, color, herb, mission. So it's pretty cool stuff, and we see this again being something, and this is another side we have with the understand jargon and leverage capabilities that fits together to be able to lead to this, which is actually what I'm going to end on a bit, and I'm sure there's folks here from IBM who can talk more about it. This is the kind of neat, when they talk about Watson Jeopardy kind of stuff for us at NASA, expert systems. These are question and answer. We have a researcher we have several researchers and a couple leads in our crew systems and avionics operations branch that have used this for what we call pilot advisor. This is the idea that as something goes wrong on a mission, or a flight, I should say, the crew, the pilot and the co-pilot could query Watson. Again, this is developmental, it's not actually deployed, but Watson would have ingested all the manuals related to that aircraft, procedures, blueprints, mechanics, specs, and would be able to say, hey, this is what I think is wrong. And the time savings for that, we see this not only on aircraft, but also on spacecraft, is obvious and straightforward, I think, for folks to see if we get something like that in time. Discussed neuromorphic chips this morning, too, and some of the military concerns. Having systems that can answer questions for us in very complex domains doesn't exist right now in very many areas. It's something we really have our eye on. And again, it's not limited to the NASA side with it either. This is the other one we did, and I put this up because it's actually cool for a lot of different federal agencies. This was regulatory. This is with when I mentioned that we're going to fly to work someday instead of drive. We know that that's going to occur. We know for that to occur, we have to have an entirely new regulatory space. It's cool to think Jetsons, you can just fly everywhere, but 95 is 95 for a reason, and that's what the sky's going to turn into. So we have to understand what regulations, what safety protocols do you put in place. And a good thing to look at with this is a proof of concept that we did was to say, well, self-driving cars really have this same dynamic right now. So what if we try to pull in some information and come up with a system where our researchers who are trying to understand all these complexities and variables can put the pieces together and say, well, you know what? Maybe we need to focus this amount of effort on understanding regulatory and this amount on R&D. Again, both of these are proof of concepts. Put them up, again, at an IBM event, not to endorse, but simply to make you aware. That's what we're working with. We work with quite a few open source techniques as well. And again, I'll end on this slide. And I put this up the top there. This is the NASA, I shouldn't say it's, I believe it's our value statement, mission statement, not a motto. Reach for new heights, reveal the unknown, so that what we do and learn will benefit all humankind. And so what I would say is, and kind of an ambassador to NASA, I put up that first slide to say I'm not from every center. We've got 10 field centers and headquarters. But if you're interested in talking to us, please talk to us. And I know my counterparts at the other centers would be willing to talk to you as well. NASA does some cool stuff. We have lots of folks like me who can put it in everyday speak, so you don't necessarily have to come to the table with a PhD to understand what we talk about. Our center's very are leaning forward with this and straightforward in saying we want to partner as well. Our leadership right now says after 100 years, we want to be back in the forefront as the center that leads the way. So again, put that out as an open invitation to everyone. We're happy to talk more about this as well. So that's what I've got. Thanks for the time. Great talking with everyone, and I'll be around this afternoon too, certainly to answer questions offline as they come up.